Hello everyone, today we are starting with the organic chemistry, and in this organic chemistry the main important player which we deal is the carbon. AR carbon. Okay, this carbon is represented in the form of the capital C, and it has the atomic number as 6 and the mass number as the 12, and it has the important property that it can have a property of the catenation, means it can form a bond with itself in a number of way, and like this it has formed with another carbon. This is another carbon and can form a long chain of this carbon chain. This is property is called the catenation property, and this carbon can form the covalent bond. Okay, covalent bond is a very strong bond, and it can form the covalent bond with compounds such as atoms such as hydrogen, oxygen, nitrogen, sulfur, phosphorus, and the halogens such as chlorine, fluorine, bromine, iodine. Okay, and earlier it was taught there is some kind of the vital forces that acts. These are some of the mysterious type of forces that act and makes the organic molecules or the organic compounds, but it was disproved by the contradictions. And for this, what the scientists do, they make the urea from the ammonium cyanate. Okay, what is ammonium cyanate? It is an inorganic molecule, and from that they synthesize that the organic part, and from there this approved that there is no any such mysterious force. They can be formed the organic compound from the inorganic part. Similarly, the another scientist called the Colway synthesis the acetic acid, and the methane is synthesized by the another scientist from the inorganic part. From inorganic they form the organic compound, and there is the special way how to represent these organic. In the organic chemistry we represent the compound or the structure in a different form. There is a structure formula. In the structure formula, what we do, there is, like, take an example of the methane. There is carbon. It forms the 4 covalent bond with a hydrogen, and this is called the this is the structural representation of the methane. And likewise there is the ethane. In this ethane, what is, there is a carbon, there is another carbon came, and we have the 3 hydrogen each. Hydrogen, there is another hydrogen. There are 2 compounds, and the valency is satisfied. We can see that it has the 4, 1, 2, 3, 4. Similarly, 1, 2, 3, 4 valency is satisfied, and this is called ethane. Similarly, in the propane, the 3 carbon chain, there is a 4 butane, there is a 4 carbon chain, C, and here we can see all the hydrogen will be filled, and these are the structure formula. And if we, and there is the condensed formula also, because in every place we can't write this expanded form. This is, we can For writing this there is a need of lot of space and there is a need of lot of time also, so we make it in the condensed form. Short condensed means short. Okay, and what we do, we simply write the carbon and the hydrogen. Okay, there are how many carbon in this? 1 2 3 4 5 6 carbon, and we count the hydrogen in this. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 is the 14 carbon hydrogen. Okay, so this is the condensed formula. Similarly, the condensed formula for this is the CH4. Okay, 1 carbon and 4 hydrogen, and for this there is the C2H6. Okay, C2H6 is the condensed formula for ethane. And what is this? This is hexane. Hexanes means the 6. There is the 6 carbon chain is called the hexane. And another simplified form of making this bond, making this formula even easier, and is the bond line structures. In this we forms the zigzag. Okay, and each zigzag structure is each point is denoted as 1 carbon. This is 1 carbon, this is 2nd carbon, this is 3rd carbon, this is 4th carbon, this is 5th carbon, this is 6th carbon. Okay, these are the structure of the bond line structure. And in this organic compound are basically of the different types, and we will deal about these all organic compound in this lecture series. And in this, these organic compound are divided into 2 parts, basically in the acyclic or the open one, whereas the other is the cyclic or the closed chain or ring. There is something that is opened and there is something that is closed. This is cyclic form, this is the cyclic form, this is cyclic form. Okay, this is cyclic form. And in the cyclic form also we have the distribution, such as there is a homocyclic or it is the heterocyclic. Again it is further differentiated between the homocyclic. There is the alicyclic or the aromatic. In aromatic it is further differentiated between the benzenoid and the non-benzenoid. We know that this is the benzene ring, and if some compound contains this benzene ring, this is called benzenoid, and those don't contain this benzene ring are called the non-benzenoid. After this, there is a need for the proper naming of these organic compounds. So there is a term called the IUPAC, system of nomenclature. So we need the nomenclature system in which we can name these all compounds, and this can be understood by all the people in the world, and this can be easily be understood, and this is the universal naming. Okay, and it is fixed for a compound. So to avoid any kind of confusion, so there is no confusion after getting this IUPAC name, because they are very specific for the specific compound, and the specific name is given to these, and there is a no overlap of these name. and there is the proper rule how we give this name. Is the first we write the secondary prefix. If it has any secondary prefix, then we add the primary prefix, then we use the word root, then we use the primary suffix, and then we use the secondary suffix if it has any. Okay, this rule need to be learned by heart for naming any compound in the IUPAC naming, and these have the also there is a some one thing that you remember or that you have to remember is the functional group preference order. For a naming of any of the compound, we need to assign a numbering system, and for assigning numbering system we need to know to which compound we should assign the numbering one and more preference to that of the others. So this is a table given by the standard system, and in this we can see the COH, the carboxylic group is given the primary or the most preference, then that is SO3H, and the COOR. R means any kind of the other group that can be anything like here the Cl or anything the and another is the COCl, after that CONH2, then after the Cn, then CH double bond O, and there is the more preference given to C ketone, then hydroxy, then NH2, then the carbon double bond, and the least preference is given to the triple bond. And there are the functional group, functional isomers that are looking the same in formula but different in structure. Okay, these are the functional isomers such as the alcohols and ethers. Alcohol contain the OH part and the ether contain the this O only. There is the aldehyde and the ketone, C double bond O and CHO is the another is the carboxylic acid, and the ethers COOH, the ROOR. Then comes the another isomers that are the cyanide. There is the cyanide and the isocyanide. These are the CN and the NC. These are the functional isomers.